Going back to I started with heat pumps in 2007. It was all ground source heat pumps back then. Air source wasn't even a thing. Air source has become more popular in the last 6-7 years. But if I look back to them installations done almost 20 years ago with the ground source heat pumps, they've been really reliable. I mean, really reliable, and so much so that there's a few of them that we've never been back to. We do like to provide an ongoing preventative maintenance contract, just to make sure everything's right. But some people tend to do that and take you up on that offer. Other people wait till it breaks and then call you. Either way, we'll try and maintain the system, because once you're a daily customer, a B2B customer, you're a customer for lifetime, and we look after the system going forward. Then back to the point about the differences, I suppose the main difference with ground source over air source is that one's collecting the heat from the ground, so you have either a borehole or a horizontal collector, and the other one's taking the heat from the air outside. The refrigeration cycle works very similarly for both, but with you taking heat out of the air or the air source, once you build up a layer of ice or frost in the winter months, which will happen, the air source has to do what's called the defrost cycle. So that takes about 3 to 5 minutes to do that cycle. And what it actually does, it reverses the cycle and takes heat back from the house. So that makes it slightly less efficient than a ground source system, because we don't have to do that with ground source. Typically, the temperature in the ground is always in around 10 degrees on average in Northern Ireland. So that's a stable temperature. And it just means your COP, your coefficient performance, should always be higher with a ground source system. The reason air source has become more popular in the last few years is that it's just capital cost. It's a lower cost to put it in because you don't have the associated civil cost. But recently, like our partner EcoForest, they've brought out a new product called an EcoGeolite, a 6 kilowatt ground source heat pump, which is really competitively priced to the point that we could almost match the cost of an air source system by putting in the same equivalent ground source heat pump. So you can probably tell from talking to me, I'm more passionate about ground source because that's what I've been used to for so long. I've known how reliable it is. It's not to say air source doesn't have its place. Typically for retrofits, air source could be a better option. But it just we look at the project on a case by case basis and sort of work with the homeowner and advise them what's the best to go with. The other last thing to mention about heat pumps is that they can both heat and cool. So typically, if you've got a house that requires a bit of cooling in the summer, which has become more and more popular, the ground source heat pump can cool your house effectively for free because it's taking that temperature in the ground and transferring that into your house. You can also cool with an air source heat pump, but you actually have to run the compressor and produce that chilled water to get the same cooling effect. Yep. So that's another advantage, I suppose, of ground source heat pumps. So typically, you can install a heat pump without having solar PV on your roof. In fact, if your budget's tight, we'd say that people get your heat pump, put that in now, because that's a harder system to retrofit. It's a lot easier to put panels on your roof in a year or two's time. So you can run it. Obviously, there'll be a higher running cost to just run your heat pump without it being offset by solar. Typically, we would see systems where the solar could offset the running cost of the heat pump by between sort of 40 and 50% would be quite common. So most houses would be suitable for PV as long as you have sort of an east-facing roof, a west-facing roof, or ideally a south-facing roof. Typical system can range from sort of 6 panels on average on a decent-sized house up to about 16 panels. So each panel is about 1.8 square meters in total. So you work that out and sort of look at your roof and see, well, can I get 1.8 times 6 panels on the roof? Then it would be suitable for solar. Probably the main benefit of solar, a lot of people obviously work from home now. So if you're at home throughout the day, the advantages are it's a better system to do because you're obviously creating electricity during the day. And if you can use that as much as possible, switching on different appliances throughout the day, then you're getting more benefit. If you're not there throughout the day, you can look at the option of a battery, adding battery storage to the system. But we would sort of advise people, don't put in the battery straight away. Try and get a flavour of what your PV's doing, how much is it offsetting your running cost of your house. You get all this data from the app, so you'll be able to see on a daily basis, on a monthly basis, what your savings are. And then that would give you great info in a year's time as to what size of battery you would need. New houses being built now, we get asked the question, and it's a big one obviously for architects, is does my house need a plant room? We'd say most definitely yes. A plant room that is central in the house is a brilliant feature, and in terms of keeping our systems efficient, you've got shorter duct runs. All your duct runs to your ventilation system are of equal length, which helps with the efficiency. Your underfloor heating manifolds are central again, just nice continuous even runs to all the rooms from a central point. Makes a huge difference to the performance of the system. It also means that when our engineers come to service the equipment, we're going into one room in the house, which is nicely kitted out with all the gear, and so we have to go to one point of your house to service that equipment. If you haven't considered a plant room, typically what ends up happening, you'll have to say to the homeowner, well, your heat pump has to go in your utility room, your hot water tank has to go in your hot press, mechanical ventilation system, don't know where to put it, we'll have to put it on the attic space. But then we go to service that, we're going throughout your house and stuff. So it's just a small thing, but it's another thing to consider. But the main thing is just we are not the ones bringing the disappointing news to the homeowners to say this needs to go here, here, and here, when they've already thought about using them rooms for other things. So it doesn't have to be big, something that's typically 2 by 2.5 meters, that sort of size, backing onto an outside wall would be ideal for us. And that means we can get our heat pump, we can get our hot water tank, we can get our ventilation system all into the one unit. Come back to my earlier point about the heat recovery. If that's within the thermal envelope, all your ducting's within the thermal envelope, you will definitely see efficiency savings there between 20 and 30%. So looking at the different technologies you have in the home, the ground source heat pump, we'd all say to people, get that into the house. Don't ever consider putting it in the garage. Like, it's funny when you look back 10, 15 years ago, everybody put their oil boiler at the back of the garage and had a 20, 30 meter pipe run over the house. Like, for us, that's just a no-no. You want to start your heating production where you need it the most. So a heat pump, typically a ground source heat pump, is 600-700 mils deep, depending on the unit model. It's about 600 mil wide and just over a meter high. And then we need a small bit of space either side for service and access and for pipe work. So typically you can fit into a space about 1.2 meters by about, say, 700 mil. And then your hot water tank is usually around 600-700 mil in diameter and about 2 meters high. I'm glad this is a frequently asked question here, because it is something we get asked all the time. Will we have enough hot water with the system? Will it be hot enough? Will we run out? Will we have to boost it? The simple answer is no. You never have to do any of them things. You'll always have hot water on demand. So a heat pump works with a sensor in the tank, and it'll always maintain a temperature. We tend to heat that tank to a certain temperature, sort of between 45 and 50 degrees. You don't have to, when you go to do your dishes, you don't have to add cold water to your sink. So you're not heating it to a higher temperature than what you need to, and then cool it down again by adding cool water in. So there's always hot water. And with the EcoForest e-manager system, for example, we will also boost that water up to 60 degrees on a day when solar is driving that driving the heat pump to produce the hot water to a higher temperature. So whenever the PV and the heat pump work in tandem, we can actually say, if we have a bigger cylinder, we'll heat that tank up to 55, 60 degrees without using any backup immersion. So in every project that we've ever done, I don't think I've ever remembered a case where people have phoned up to say, oh, we don't have enough hot water. It's not an issue. So it's not. Yeah, so on the question about the backup heater, it's not required, especially for new builds. If you're building a new building and you've got control over the insulation or tightness of fabric measures, you should be designing that system that it doesn't need a backup system. We've done heat pumps in domestic and commercial without any form of backup, and the backup's never been required. It's different for retrofits. It's sort of case by case basis. We've done a lot of retrofits over the years, but even in that, about 90% of them, we've replaced the oil or gas boiler with a heat pump and done away with the boiler, so it's become redundant. there's been a very odd case where we thought the heat load here could be slightly higher than what the heat pump can give it in the coldest days of the years. In that case, that we've kept the backup boiler there, just to supplement it. And that could be running maybe 3-4% of the year, so the heat pump's doing still the bulk of the work. Yeah, so we sit down with a homeowner or architect building their new build home. We're discussing with them insulation, air tightness, thermal bridging, because we know that if all them measures are done, our system will perform really efficiently and you'll have really low running cost. So if you're going to do them measures, which we regard as important, you need a mechanical ventilation system to provide continuous filtered fresh air to every room. It's self-defeating by having a 150mm cavity and 200mm insulation in your floor, and then you have a triple vented window, which on a cold winter's night, if the wind's hitting that side of the house, that's just changing your air change rate from half an air change to 3 air changes per hour, and then your heating system has to react to that. So our system, the mechanical ventilation, heat recovery, you're getting filtered fresh air into every room in around 16, 17 degrees, and it's just a gentle flow of air, and it's just helping the heating system to maintain that comfort level in the home. You don't have any extract fans in your bathroom. As I say, you don't have trickle vents with this system. You don't have to open windows in the winter. You can still open the windows in the summer, there's no problem. But in the winter, you keep all your windows and doors closed, and you get nice filtered fresh air into the room. In a previous house we lived in, we actually retrofitted a mechanical ventilation system in an older house built in the 1980s, because we had issues with mold and condensation in the bathroom and the bedrooms. I put in an air quality sensor to monitor air quality, turned the mechanical ventilation off for a full weekend, and I could see a spike in the CO2 levels and stuff just started to rise and rise and rise over the course of 2-3 days. So that to me proved this system was doing a job, and we had a young family at the time, and I could sleep easily at night knowing that my kids are in an environment where they've got nice, healthy, fresh air coming in, which is filtered, and it just creates a nice, crisp, clean environment. So a typical maintenance visit with us, we typically maintain the hot water tank, the heat pump, the mechanical ventilation, so we'll do all that in one visit. But when it comes to the heat recovery, you'll be obviously changing your filters, replace them initially after 6 months, we would say to people, but then every year after that, depending on what environment that you're in. You'd also take out your heat exchanger and clean it, check the fans are operating okay and give them a clean, and also check that your condensate drain is still draining away freely. So there is a good 7 or 8 things there to check. People think it's sometimes a matter of just taking filters out and putting new filters in, but it's more preventative maintenance, and then making sure the system's nice and clean, it's performing correctly, and then it's not going to break on you when you least expect.